These are the video notes for factoring and solving polynomials test review. So I'm going to go through an example problem in each section just to help prepare for the test. So let's jump right in. The first section is called two terms, difference of squares. And by squares, I mean perfect squares. The directions ask us to factor each polynomial. So that's the first thing we need to do. And then find all the roots. And roots is just another term for zeros or solutions. So the first problem is 9x squared minus 25 equals 0. So each of these expressions is going to be a perfect square. So the first step is to simply take the square root. So we'll take the square root of 9x squared. The square root of 9 is 3, and the square root of x squared is x. Then we'll take the square root of 25. The square root of 25 is simply 5. And so our answer is going to become 3x plus 5 and 3x minus 5. So we're taking each of our results from taking the square root and putting them together in two binomials with a plus or minus sign between the terms. Now you could certainly write, this is called factored form, you set it equal to 0. Now you can certainly write it with the minus sign first and then the plus sign. So the order of the plus and minus signs don't matter. So if you want to write this as 3x minus 5 times 3x plus 5 equals 0, that's certainly fine too. The second part of the instructions were to find all the roots. So we're going to set each factor that's in parentheses equal to 0 and solve for x. So we have 3x plus 5 equal to 0. Move the 5 across the equal sign so it becomes a negative 5. And divide both sides by 3 and we get x equals negative 5/3. Over here we'll do the same thing, except since it's a negative 5, when we move it across the equal sign we get a positive 5. And then divide both sides by 3 and we get x equals 5/3. So our answer is x equals negative 5/3 and x equals positive 5/3. If you want to simply write plus or minus 5/3, that's fine, and you can include or not include the curly brackets. It doesn't matter. Now, I want to look at one other problem in this section, but we're not going to actually solve it, and it's problem number 3. Problem number 3 is x to the power of 3 minus 4x equals 0. And at first glance, it doesn't look like a perfect square because of 3. It should be a 2 here, right? But notice that the second term also has an x. So it's 4x to the third minus, x to the third minus 4x. So the first thing we actually need to do is factor out a GCF, the x that's common to both these terms. And when we do that, we end up with x on the outside and x squared minus 4 are leftovers on the inside. X squared minus 4 is a perfect square, so we can move forward with the same formula again, using a difference of perfect squares. All we have to do, or remember to do at the end, is set that x equal to 0. It's a part of the solution, right? We should have 3 solutions here. So we're just going to have the solutions from a difference of perfect squares, but also where x equals 0 as well. All right, next section, two terms and the sum of cubes. So let's start off with a fairly easier example, and then we'll do one in the section that's hard, because all of this is new to us. So we would not have seen sum or difference of cubes in Algebra 1. Okay, a couple things we're going to need to know getting into this. First, whenever I think of sum or difference of cubes, the word cubes comes to mind. SOAP for the plus or minus signs. Same, opposite, always positive. The other thing that comes to mind is that I'm going to have to use the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, remember or recall that the a is the number in front of x squared, the b is always the number in front of x, and the c is the constant term. A, B, and C all represent numbers. They do not include variables, just the numbers. Okay. So let's jump right in with number 5. We'll get started. You've got two terms here, a plus sign between them, and I noticed that the exponent for the variable is a 3. That makes it a cube, and that's why I'm going to use the formula for the sum of cubes. So the first thing I'm going to do, just like before, is I'm going to take the cube root because it's x cubed, and that gives me x. Those 3's actually cancel each other out. I'm going to do the same for 216. I'm going to take the cube root of 216. And let's make sure we all know how to do that. So let me get my calculator out in case you can't do that in your head. Ideally, remember you were supposed to memorize those perfect cubes if you didn't know them. but I'm going to show you, you'll be able to use your calculator on the test. So another way around that problem is if I want to take the root of something, I'm going to hit, in this case, the third root. I'm going to press the number 3. I'm going to hit the second key, and I'm going to hit my exponent key. Now it's my root key because I hit the second key. That 3 replaces that little x that you see there. So you're saying I want the third root, and then you just simply type in the number, in this case 216, and you hit equals, and that gives me the answer of 6. So I know that the cube root of 216 is 6. Now, the next thing I need to know, make sure I know for the sum of cubes, is the formula. So in the formula, this is my first term, this is my second term or last term. I'm going to write it together in a binomial, x plus 6. Now, why choose the plus sign? Because we're choosing the same sign as the original polynomial. Now, what do I do to get the rest of this? So right after a binomial, I'm going to write a trinomial. The formula for that is square the first term, so x times x is x squared. Multiply the two together, so 6 times x is going to be 6x. And you can multiply x times 6, but always remember when you write it, put the number in front of the variable. And then the last term is going to be 6 squared. 6 squared will become 36. Now, in terms of the plus or minus signs, we've already said this expression, the binomial, inherits the same sign as the original polynomial. The next set of terms will have the opposite sign between them, so a negative, and between the middle and the last terms, it will always be positive, so a plus sign there. So the only thing we have to do in terms of moving from this step to this step is go ahead and square 6 squared. That becomes a 36. Then at this point, we've got factored form. We can't factor this. I will tell you that right now. You're not going to be able to factor this trinomial. If you come up with a list of numbers that multiply by 36 to get 36, that's fairly easy. But none of them will be able to give you a negative 6. So just prepare for that in advance. So this is my factored form. I cannot factor this any further. So I have x plus 6 times, in parentheses, x squared minus 6x plus 36 equals 0. So that would go up here as my factored form. The next step is to write down or find the roots. So for the binomial, that's simple. We set x plus 6 equal to 0, solve for negative 6, sorry. And if I was you, I quickly write that negative 6 on the line where it says roots. That way you don't have to forget or try to remember to write it later. You might forget about it and you don't want to lose credit for writing that or not writing that answer even if you've actually found it. For the trinomial, this is in quadratic form, meaning the biggest exponent is 2. So this is when we start to use the quadratic formula. So I'm going to come down here and write 1 times x squared minus 6x plus 36. Notice now I've inserted a 1 here. If you have a term, so you can actually see the variable, but there's no number in front of it, it's a 1. If it was a 0, the x squared wouldn't exist, right? 0 times x squared would be 0. But it's a 1 here. So we've got 1x squared minus 6x plus 36 equals 0. That means a is 1, b is negative 6, and c is 36. Now all I'm going to do is plug them into the formula that I wrote down earlier. So when you get your test, if you're worried about remembering the quadratic formula, I would write the quadratic formula on the page with sum or difference of cubes right off the bat, because that's where you're going to need it. And that way, if you write it first, you'll probably be guaranteed that if you forget it later, you don't have to worry about it. You've already got it written down, and it'll give you a little bit of sense of peace before you start the test. Okay? So the formula is x equals negative b. So if b is a negative 6, you're going to take a negative 6. So two negatives make a positive when you multiply them together. So this is going to become a positive 6. So knowing that, some people just take the b and write down the opposite sign. So if this is negative 6, they just write down a positive 6. Then it's plus or minus. Don't forget that piece. It's often forgotten, and people multiply this term by the square root. And that's not the case. You need to get two solutions, and that's what the plus or minus is for. So then you take the square root of b squared, which is negative 6 squared, minus 4 times a, which is 1, times c, which is 36. All over the whole thing, not just the square root piece, but the whole thing over 2 times 1. All right? So as I said before, when you multiply a negative 1 times a negative 6, you're going to get a positive 6. plus or minus, and I would go ahead and put this whole expression in your calculator. Now, you don't want to put the square root sign, or you don't want to square root it in your calculator because you don't know if you're going to get a negative number underneath here, and then you'll get a syntax error. Plus, if it's not a perfect square, you'll get a decimal answer. So you just want to put negative 6 squared minus 4 times 1 times 36, or even better, if you feel confident, multiply that, square it, subtract it, multiply it in your head, and then check your answer using your calculator. So if you do that, you get the square root of negative 108. So there we go. Now what do I do from here? First thing I'm thinking is the negative sign, I want to go ahead and separate that out. So this is going to be 6 plus or minus the square root of 108 times the negative 1. Remember what that square root of negative 1 is going to become. It's going to become I. So, and then all I have to do now is focus on 108. What is the biggest square that divides into 108? And so just to help you along in that process, if you need to, one of the things I would be doing right now, if I wasn't sure what it was, I'm going to take 108 divided by 2, and that gives me 54. So I know it's going to be a perfect square that's equal to or less than 54. So I'm thinking 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64. Well, 64 is too big. So I know that 108, it's not a prime number, so that means one of these numbers is going to be, besides 1, since it's not prime, it's divisible. So if you need to divide, try to divide 108 by 49. 108 divided by 49 gives me a decimal answer. That tells me that that number doesn't go evenly, meaning I would have no, it wouldn't be a decimal, I'd actually have the answer. So that means that 49 is off the list. 49 does not divide evenly into 108. So then I try the next number, 108 divided by 36. This time I get 3. So 36 is the perfect square that divides evenly into 108. So then I scooch up to get to the bottom. So I'm going to go ahead and break this up. Remember what we said. 36 divides evenly. We get a quotient of 3. So I'm going to break up the 108 into the square root of 36 times the square root of 3. And then again, we know this square root of negative 1, which will become I. So when we put it all together, it's going to be 6 plus or minus the square root of 36. Always take the perfect square first. Will become 6. The square root of negative 1 becomes I. And the square root of 3 is going to stay, 3 is going to stay under the radical. It's a prime number, so there's no way it's coming out. That always gets written last. So the only thing that would ever get written behind a radical is a variable. And then all of that divided by 2. Now, ideally, I'd like to be done, but let's take a moment. 6, 6i, and 2. All of those are even numbers, which tells me all of them are divisible by 2, at least, if not 4. But 4 does not go into 6, and 4 is too big for 2, so it's going to be 2. So I'm going to divide 6 by 2, get 3, 6i by 2, and get 3i. I'm not going to touch the radical. That's not part of the process. It's inside the radical, not outside, so we don't do anything with the 3. And 2 divided by 2 is 1. So all of this would be over 1, but you would never write, say, 2 over 1. You would just write the number 2, right? And so by the same token, you're not going to write all of this over 1. You just leave the 1 off. So this is my answer. Let's come back up here. We already have the negative 6 written here. We're just going to add 3 plus or minus 3i times the square root of 3. And we're done. And again, curly brackets are optional. All right, so let's try one more of these. This one's a little bit trickier. It's 27 x times x cubed minus 1 equals 0. Okay, let's get started. Oh, sorry, I think I might have to sneeze. So first thing I'm going to do excuse me, sorry about that, is take this cube root of 27x cubed. The cube root of 27 is 3. The cube root of x cubed is just x. And then take the cube root of 1 as well and get 1. And again, if we need a little help in this department, I can type in, let me scooch this up, take in the 3, second and then hit this key right here, the V. Sometimes it says Y to the X. And then type in this case, the number 27, hit equals, and I get the answer 3. And I can do the same for the 1 if I'm not sure. So 3, second key, then the upside down V, or it might say Y to the power of X, and then type in the number 1, and I get a 1 there. So now I've got my cube roots of both terms. So remember what we're going to do. We're going to, in the first one, since 27x to the power of 3 comes first, we're going to copy the 3x first. 1 is in the back, so again, I'm going to copy 1 in the back. And I'm going to put a subtraction sign because they have the same sign as the original polynomial. And then remember what we have to do. This one's going to be a little bit more complicated. We're going to take 3x and square it. Then we're going to multiply these two together, 3x times 1, to get the middle term. And to get the last term, we're simply going to take the 1 and square it and set everything equal to 0. So let's bring it down here. 3x minus 1, we're doing nothing to change the binomial, but we need to clean up this trinomial. So let's go ahead. 3x squared is like writing 3x times 3x. So 3 times 3 is 9, and x times x is simply x squared. 3x times 1, anything multiplied by 1 is just itself, so I'm just going to write 3x. And 1 times 1 is just simply 1. So here's my binomial, here is my trinomial. And again, you're not going to be able to factor this trinomial. So this is factored form. So I will go ahead and copy that up here. 3x minus 1 times 9x squared plus 3x plus 1 equals 0. Now moving on to the part where we find the roots. So the first thing I'm going to do is take 3x minus 1, set it equal to 0. It's a minus 1 on the left, so when I move the 1 over to the other side, it becomes positive. So I've got 3x equals 1, divide both sides by 3, and I get x equals 1/3. I'm going to use the quadratic formula for my trinomial since I can't factor it. That's the next best thing. So, and don't forget, take that 1/3, write it up here as part of your roots so you don't have to worry about writing it or finding it later when you're doing or finding the solution to your trinomial. So let me scooch this all the way up. Okay, good. So I've got 9x squared plus 3x plus 1. We don't have to write down a 1 for a placeholder to let us know what any of the A, B, C or terms are. So we're good. A is going to be represented by 9. 3 is going to be B, and 1 is C. So we're not missing anything like we did before where we had to write the 1 in front of x squared to remind us what A is. Okay, so now let's just go ahead and plug things in. So it's x equals negative B. So we're going to put a negative sign in front of the 3, plus or minus the square root of B squared, so 3 squared minus 4 times A, which is 9, times C, which is 1. All of that underlined over 2 times A, which is 9. So be careful here. A lot of times people always assume A is 1, so they just put a 2 in the denominator. It's actually 2 times 9. So it's going to be negative 3 plus or minus. And again, at this point, I would do mental math if I could. And if you can't do the mental math, that's fine too. Just put it in your calculator. And you should get a negative 27. And better yet, if you can do the mental math and check it with your calculator, that's really the way to go. And that'll help your mental math skills improve. So I've got a negative 27 here. So again, my first step is to separate that negative sign out. We know that the square root of negative 1 is going to just become an I. So we kind of don't need to worry about that piece right now. What we really need to focus on is the 27. And you could do the same thing if you need to that you did before. We could take 27, divide it by 2. That gives us 13.5. So I'm looking at all the possible square roots that are less than 13. So I'm thinking that takes all of this off the list. So that only we have to look at 1, 4, and 9. That makes things easy, right? So if I take 27 and start with 9, look what I get, a 3. So we can break 27 down into the square root of 9 times the square root of 3. So I've gone ahead and done that. So I have negative 3 plus or minus the square root of positive 9 times the square root of 3. Notice that I always write the perfect square first because that's going to be outside the radical. So I'm just sort of setting myself up and I don't have to rearrange things later. And then last but not least, we still have that square root of negative 1. Don't forget about that. Some people let that drop off. We don't want to do that. If you're nervous about that, then change it to I immediately and write the I out front here instead of waiting to change it later. All right, so let's scooch down. So now I have -3 plus or minus, the square root of 9 is 3, the square root of -1 is I, and then the square root of this 3 will stay underneath the radical. And it's all over 2 times 9, which is 18. Now, I'm looking at 3, 3, and 18. We happen to have the bigger number in the denominator this time. So I'm going to say if maybe, does 3 divide into 18? Yes, it does. It goes 6 times. So I'm going to go ahead and divide -3 by 3 and get -1. Take 3i, divide it by 3 and get 1, or just I. So you can write 1i here, or you could just simply write the I. I'm not going to touch the 3 underneath the radical because it's underneath the radical. We're working with these numbers because they're all outside the radical. And then last but not least, 18 divided by 3 is 6. So now I have simplified my solution. So my answer is going to be -1 plus or minus I times the square root of 3 divided by 6. So I'm done. Moving on to the next problem. Okay, so these are trinomials where a equals 1. And when I say that, what I mean is the number in front, remember ax squared plus bx plus c, the number in front of x squared is a 1. So there, you don't see any number there. So know that it's a 1. It's not a 0. If it was a 0, 0 times x squared would mean that this x squared term would go away. So that's not the case. All right, so if you can do this with mental math, more power to you. But I'm not going to assume that anybody can. So if you need to do a little work, here's your scratch work. This is what I'd be writing down. So the first thing I'm thinking is two numbers. In fact, let me go ahead and write A, B, C. Two numbers that multiply to get C, or the last term, which is 20. And those same two numbers, when you add them together, they have to combine to get the B term, or the middle term, which happens to be -9. So -4 times -5 give me a +20. -4 plus a -5 give me a -9. So this is your last term, and this is the middle term for the original polynomial. So these work. So this is nice and simple. And let me back up for a minute here. If you're not sure what numbers to use, make a list. So always start with what numbers you're multiplying to get 20. So 1 times 20, 2 times 10, 4 times 5. All of those numbers, when you multiply them together, will give you 20. Out of this list, which row is going to give you a 9? And the only one where you could possibly get a 9 would be the 4 and the 5, because you could add them together to get 9. But in this case, it needs to be a -9, so both numbers need to be negative. So that being said, once you've found those your two numbers, all you're going to do is put them together in two binomials. So you're going to create the parentheses, split the x squared, put an x in the front of each one, and then you're going to copy -4 in one and -5 in the other. Now, can you do the reverse? Can you write x minus 5 times x minus 4? Absolutely. It doesn't matter what order you write them in. So I'm going to copy, that's factored form, so set it equal to 0. Write your factor set equal to 0 up here. So x minus 4 times x minus 5 equals 0. And then all we have left to do is set each factor equal to 0 and solve for x. So x minus 4 equals 0. Move the -4 to the other side of the equals, and then it becomes a +4. X minus 5 equals 0. Move that 5 across the equal sign so it becomes a +5. So I get x equals 4 and x equals 5. And you can write it just like that on the line for the roots, or you can just write the 4 and 5, or you can write the 4 and 5 in the curly brackets. All of those are perfectly acceptable ways of writing this solution. All right, now let's do one that's a little bit more tricky. This one has a number besides 1 in front of the a squared term. So it's trinomials, meaning 3 terms, 1, 2, 3. Remember, trinomials are separated by plus or minus signs, but the a is greater than 1. So that you don't no longer have a 1 here. It could be 2, 3, 4, 5, whatever number is bigger than 1. So in this case, we have 5x squared minus 8x minus 4. So our a is 5, our b is -8, and our c is -4. Now, Technically, could you use the quadratic formula to find the roots? Yes, you could, but you wouldn't get the factors out of that. So while anything that's in an x squared form, you can go ahead and use that to find the roots, it won't give you the factors. So we have two choices. We could use guess and check, or we could use bust the bee and factor by grouping. I'm going to walk you through both methods. And again, you choose and worry about and focus on the method that's best for you. There's no sense in learning both of them. That'll make things confusing. So I'm going to use guess and check first. So I've got 5x squared minus 8x minus 4 equals 0. So where to begin? The first thing I'm going to look at is the first and the last term to see if they're either one of them or both of them might be prime. In this case, 5 is prime. That means that the only numbers that multiply to get 5 are 1 and 5. 4 is not prime because I can multiply 1 times 4 or 2 times 2 to get 4. So that makes it not prime. Okay, so I'm going to go ahead and create two sets of parentheses, set them equal to 0, and because 5 is prime and it only breaks down into 5 and 1, I'm going to put 5x in the front of one set of binomials or parentheses and 1x in front of the other set. Now, I didn't write the 1 here. You are more than welcome to write the 1. It is not necessary. It's strictly optional, so I just chose not to write it. So I'm down to right here. I've got 5x in the front of one set of parentheses and the x in the front of another set of parentheses. Why do I write it in the front or first? Because the 5x squared term is the first term in this trinomial. Next, I have to figure out what number combination is going to work in terms of foiling the inner and outer terms. So first things I need to do is make a list of all the terms that multiply to get 4. So I could multiply 1 times 4, or 4 times 1, or 2 times 2. And then this becomes trial and error. This is your guess and check piece. So if I try, and some of this you may be able to figure out on your own. For example, if I put a 1 here and a 4 here, 1 times x is 1x. 4 times 5 is 20. There's no way if I have a 1 and a 20, I'm going to get an 8. So I know that that's not even an option. So I would scratch that option off the list. Then here, if I put a 4 here and a 1 here, that's going to give me 4x and 5x. So that gives me 9x. So that number's too big. That's not going to work either. So 4x and 1x would give me, would that work? 4x and 5x would give me 9x. Yeah. So if I add them together, if I subtract them, I get 1x, so that still doesn't work. So finally, I'm down to 2 and 2. So 2 times x is 2x. 5x times 2 is 10x. Look at what I'm doing here. I'm foiling the inner terms or multiplying them together. So when I say foil, I'm really just multiplying them together. So 2 times x is 2x. 5x times 2 is 10x. I can actually get a negative 8x if I make the 10 negative. The bigger number has to be negative, so I get a negative 8x as a solution when I add these two together. So for that to work, then 2x obviously has to be positive. So I'm going to plus a plus sign in front of 2. For the 10 to be negative, I'd have to put a negative sign in front of this 2. So this is going to be 5x plus 2, x minus 2. Now we know that when we go ahead and multiply the inner and the outer terms and add them together, we get negative 8x. That's the middle term b. So we're good there. Let's do one final check to make sure that all of this works. Let's multiply 2 times negative 2. That gives me negative 4. That is my c value, or my last term. So then we know for sure that this is the right solution. Sometimes there is more than one combination in this list that'll give you your b value. Doesn't happen often, but it does occur. So you always have to check and make sure that if you multiply these terms, once you get them, that you multiply them together to be sure that you'll still get the last term. Sometimes you'll end up with a positive when you need a negative, and so you know you didn't quite get it, and you have to pick another row in your list of terms that multiply to get the last term. So once we've got this 5x plus 2 times x minus 2, we set that equal to 0. That's factored form, so we're going to copy that answer up here. All we have to do at this point is find the roots. So I'm going to set 5x plus 2, one of the factors, equal to 0. move the 2 across the equal sign to the other side, so it goes 5x, and it becomes a negative 2 on the right. Divide both sides by 5, and we get x equals negative 2/5. And I'm going to write that answer up here. And now notice, and then I'll go ahead and do the next one, x minus 2. When I move the negative 2 across the equal sign, it becomes a positive 2. Now, I want to show you something here. Notice that the factors I wrote down here were 5x plus 2 times x minus 2, but when I wrote them up here, I wrote x minus 2 times 5x plus 2 equals 0. That's because order doesn't matter. So whether you write the x minus 2 first or the 5x plus 2 first, that makes no difference. What you can't do is switch the plus or minus signs. This expression or factor has to include the minus sign, and this one has to include the plus sign. So it's important that you get your plus or minus signs right. But in terms of the parentheses, which set of parentheses you write first makes no difference. And then I did the same here. I found negative 2/5 and 2, but when I wrote the answer, I wrote it in the reverse order, 2 and negative 2/5, to show you it doesn't matter which order you write the answers in as well, that you can just make the list. Ideally, it's nice if you can write it from least to greatest, but it doesn't matter. In the end, I'm just going to be checking that you have 2 and negative 2/5 written as your solutions for this polynomial. Now, let's say you're not a guess and check person and you'd rather do factor by grouping. So let's talk about that. Let's do that as well. So on first glance, it's sort of like if you try to solve this problem as if the a value was 1, it won't work. You've got 5x squared minus 8x minus 4 equals 0. Well, we already know from up here, the numbers that multiply to get 4 are 1 and 4 and 2 and 2. So if I come down here, there's no way to get a negative 8 out of that. Those numbers aren't big enough. So that should be a red flag that you need to use the B factor by grouping approach to solve this problem. So you can do that because it's a quadratic. So what I'm actually going to do is I'm going to take the 5 and multiply it by negative 4. In other words, I'm going to multiply my A term by my C term. 5 times negative 4 is called negative 20. And this is actually for some people called the AC method. So if you're trying to Google some videos, and you could Google AC method, and then this will come up as a method for solving. So now what I'm really looking for is the numbers that multiply to get negative 20. And when I combine them, I get negative 8. So I'm going to do a little scratch work down here. So two numbers that multiply to get negative 20, or A times C. And when I combine them, meaning you add or subtract them, you get negative 8, or the B term, so the middle term. So one of the first things I might want to do, if I'm not really sure which combination works, is just write out all the numbers that multiply to get negative 20. So like 1 times 20, 2 times 10, 4 times 5. Those are all the combinations that I can think of that will give me 20. Now, of that list, that's the list we're working from. Of those 3 rows, which combination do you think you could get an 8 out of? So definitely not 1 and 20, right? If I add them, I get 21. If I subtract them, I get 19. And definitely not 4 and 5. If I add them, I get 9. And if I subtract them, I get 1. But if I work with 2 and 10, that looks like a possibility, right? 2 times 10 gives me 20. 2 plus 10, if I add them, I get 12. But if I subtract them, I get 8. So there we go. The question becomes, where do I put the negative? Do I put it in front of the 10 or the 2? Since our answer is a negative 8, we want the bigger number to be negative. So we're going to put a negative sign in front of the 10 and keep 2 positive. That way negative 10 plus 2, and you can always check it in your calculator, gives you negative 8. And when we multiply them together, because one number is negative and one is positive, we're going to get a negative answer, negative 20. So these are the numbers that work. So when we bust out the B, we're going to replace negative 8 with negative 10 and positive 2. And because there's an x behind it, we're going to include the x when we bust it out. So I can combine these because they're like terms, right? Negative 10x plus 2x gives me a negative 8x. So I can combine them to form the B value of the original trinomial. Why are we busting them out? Because we want 4 terms. Now I have, look at what I did. I brought down the 5x squared. I brought down the first term. I brought down the last term. And I busted out only the middle term into negative 10x plus 2x and set it equal to 0. Does it matter what order I put these in? Absolutely not. You're going to get the same result. So there's no method to the madness. You could put 2x here and negative 10x here. Now, I will say it's easier in terms of the next steps if you're a little strategic in your choices. Like I put negative 10 here, not because I wrote it first down here, but I know that 5 divides into 10. And I put the 2 here because I know that 2 goes into 4. And then both the leading terms are also positive when I make this choice, so I don't have to worry about dividing by a negative number. So that makes things a little bit easier for me. So I'm being a little strategic, but you don't have to be. So then because you have 4 terms, we're going to do factor by grouping. So you're going to divide those terms in half. So you have 2 groups of 2 terms each. So look at the first 2. What do they have in common? They're both divisible by 5, and they both have a variable, so they're both divisible by x. So factor out of 5x. What's left over goes in the parentheses. So the 5's cancel out. This is x squared divided by x to the power of 1. Subtract your exponents, and you're left with a single x. Over here, 10 divided by 5 is 2. X divided by x is simply 1. So 2 times 1 is 2. So in parentheses, we're left with x minus 2. Over here, you're going to divide both of these terms by 2. This one has a variable, but this one does not, so you don't have to divide by a variable, just the number 2. So 2x divided by 2 becomes x, right? Just the x is left over, and then negative 4 divided by 2 is negative 2. Now check to make sure you got a common binomial. So we have 5x, this is my GCF, times x minus 2, plus 2, this is my GCF, times x minus 2. Now, if you set equal to 0, now if you don't get a common binomial, I would go back and check my work. So did you factor out the 5 but not the x? Did you factor out the x, not the 5? Did you divide by a negative by mistake? Or should you have divided by a negative and you didn't? So I would just go back and check. You should be able to find a common binomial at this point. So I'm going to go ahead and write my common binomial, x minus 2, and right behind it, I'm factoring that out. So what's left gets packaged in another set of parentheses, the 5x plus 2. So common binomial, GCFs, set equal to 0. Now, does it matter if I write 5x plus 2 first and the x minus 2 second? No, it does not. So my answer is going to be, this is my factored form, so I'm going to go back and copy that up here. So x minus 2 times 5x plus 2 equals 0. So that's factored form. Then I'm going to set each of those factors equal to 0. So x minus 2 set equals to 0. When you move the factor across the equal sign, it becomes a positive 2. And then I have 5x plus 2 set equal to 0 down here. When I move the positive 2 across the equal sign, I get a negative 2. When I divide both sides by 5, I get negative 2/5. So my answer is going to be, for my solutions, 2 and negative 2/5. And I'm done. So that's it. All right. These are some more problems. Then we're moving on to when you have 4 terms, factor by grouping. So if you've already done busted B and factor by grouping, this method should be fairly familiar to you. So, and it's probably smooth sailing. And you may actually want to skip this part of the video even. So you've got 4 terms, 4x to the third plus 3x squared minus 20x minus 15 equals 0. So 4 terms. So let's go ahead and again split them into 2 groups of 2 terms each. And then again, what are we doing? We're looking at for what they have in common and factoring that out. So both of these have a variable, and the one with the smallest exponent is the second one. It's x squared. So we're not just going to factor an x out. We're going to factor an x squared term. Remember, when you're comparing variables, they both have variables. Look for the one with the smallest exponent. So we can factor out an x squared term out of each one. What's left behind? 4x to the power of 1. Subtract your exponents. 3 minus 2 is 1. And then over here, x squared divided into x squared is 1. So you're just left with a 3 inside the parentheses. Now over here we have negative 20x minus 15 equals 0. Now both of these terms are divisible by 5, but not just 5, negative 5. Remember, we need to keep the leading term positive. So if it's positive, you divide by a positive number. If it's negative, you're going to divide by a negative number. So negative 20x divided by negative 5 gives me when I do that, gives me a positive 4x. This is exactly what I want. I need a leading term to be positive. And then negative 15 divided by negative 5 gives me a positive 3. So it's going to be 4x plus 3 inside the parentheses, negative 5 on the outside. Take a moment. Do we have a common binomial? Yes. If we don't, check your work. Did you factor out an x instead of an x squared term? If both these terms still have an x, then you know that you need to factor out one more x. Did you divide by 5 or negative 5? So do you need to go back and change the sign? So you should have the same expression inside the parentheses. In this case, 4x plus 3, your common binomial, and you're going to multiply that by, in the other set of parentheses, the GCFs that are sitting outside the parentheses, x squared minus 5. Set that equal to 0. So these are my factors, 4x plus 3 times x squared minus 5. So in factored form, you're going to copy that up here, 4x plus 3 times x squared minus 5 equal to 0. Then you're going to set each of those factors equal to 0. So when you set 4x plus 3 equal to 0, move the 3 across the equal sign, it becomes negative 3. And divide both sides by 4, and you get x equals negative 3/4. Over here, you're going to set x squared minus 5 equal to 0. Move the 5 over to the other side of the equal sign. Take the square root of both sides, so the square root of x squared becomes x. 5 is actually prime, so when you take the square root of 5, all you're going to get is plus or minus the square root of 5. So you're not going to be able to factor anything out of that. There's no perfect square because, again, it's prime. So my answer here is going to be negative 3/4 and negative square root of 5 and positive square root of 5. And if you just want to write the answer simply plus or minus the square root of 5, that's fine. There's nothing wrong with that. And again, the curly brackets are optional. But keep in mind, the highest exponent here is 3, so you should be getting 3 solutions. So make sure you have a plus or minus sign in front of the square root of 5. It's not just positive. Okay, that's it for that section. And all right, moving on. Using the fundamental theory of algebra, state the number of solutions for each polynomial. All right, so now up to that point, we've been finding factored form and finding the roots. So we had 2 things to do. First, we had to factor, then we had to find the roots of each of those problems. So we've been consistently doing the same thing. Now our directions are changing, so we're going to have to do a little something else. So the first problem says, use the fundamental theorem of algebra to state the number of solutions for each polynomial. So let's look at number 20 as an example. It's not in standard form, meaning it's written from the highest exponent all the way down to the lowest exponent. So in that situation, we've got to look at each term, find the one with the highest exponent. The highest exponent, or the biggest number, is 6. So 5, 6, 2, and 0 would be our choices. So 6 is the highest exponent, so the number of solutions we have is 6. We would say this is a 6th-degree polynomial. All right, let's do another one of these. Ooh, which one should we do as an example? Maybe this one right here? All right, again, our directions are changing, so we need to stop and take a moment and read the directions. This says, using the fundamental theorem of algebra, state the number of solutions for each polynomial. Find the solutions and state the multiplicity of each. Then identify the x-intercepts. So we've got a lot going on here. So let's break it down into steps. The first thing we have to do is state the number of solutions for each polynomial. So in order to do that, what we're going to have to do is it's already factored. So we're just going to have to count up the x's. That's all we're doing. So you have x to the power of 1, x to the power of 1. Now, this one's a little tricky. It's x to the power of 1, but do you see the 2 outside? Remember what exponent rules tell us to do? Exponents rules tell us to multiply these 2 together. So x to the power of 1 times 2 is going to be x to the power of 2, and then we have an x to the power of 2 term here. So these are all and I don't count all the terms. I only count the leading term. Only count the leading term. So if this was say x squared plus 9x plus 9, I wouldn't count that x. So I've got 1 plus 1 is 2, plus another 2 is 4, plus another 2 is 6. So that tells me I'm going to have 6 solutions. So that's a lot. So we've got to be prepared for it. We need to find 6 solutions. So when we look at our list of solutions, we need to verify that there are 6 of them. So this is a 6-degree polynomial if we would multiply everything out. The nice thing is we don't have to multiply it out. So the next step where it says find the solutions, that makes things a little easy. So we're going to go back up to the polynomial that we're given and go ahead and set each of these solutions equal to 0. So first thing we're going to do is take the x, set it equal to 0. That's my first solution. I'll go ahead and write that here. Then we'll take the next expression in parentheses, x minus 1, set x minus 1 equal to 0. We move the 1 across the equal sign and get a positive 1. That's my second solution. Then I'm going to take x plus 6 squared and go ahead. Now, again, it's already factored, so we don't have to multiply everything out and try to factor it. We're just going to go from here. We've already got it factored. So I'm going to take x plus 6, move the 6 across the equal sign, so it becomes x equals negative 6. But my answer will be a multiplicity of 2 because of the 2 here. If this was a 3, it would be a multiplicity of 3. So here's where my third and fourth solution come in. So I'm going to write up here negative 6 with a multiplicity of 2. So if I copy my answers right up here, I don't have to keep track of them in the end. And then last but not least, we have x squared plus 9. When I set that equal to 0, I move the 9 over to the other side. It becomes x squared equals a negative 9. Take the square roots of both sides. So the square root of x squared is x. The square root of negative 9. Ooh, remember what we want to do. Separate that negative sign out. So it's really going to be plus or minus the square root of 9 times negative, the square root of negative 1, which we know is going to be, oh, sorry, let me scooch down, I. So then this becomes x equals plus or minus the square root of 9 is 3. The square root of negative 1 we just said was I. So again, plus or minus, so that's my fifth and sixth solution. So I'm going to copy that up here, plus or minus 3i, or you can write it as negative 3i comma positive 3i. It doesn't matter. So I've got 6 solutions at this point, so I'm good. Now all I have to do is write down the the x intercepts for my list of 6 solutions. So 2 things you have to remember. Do not write down the duplicates, so no duplicates, and no imaginary numbers. So I'm going to copy down the 0, the 1. I'm going to copy down negative 6, but I only have the negative 6 once. I'm not going to write it down twice. So I'm going to leave off the multiplicity of 2. And then I'm also not going to write down the plus or minus 3i. So in this case, it's an imaginary solution, so I don't include imaginary solutions. So my x-intercepts are just going to be 0, 1, and negative 6, and that's it. Okay. Now let's look at, again, new set of directions, so something else to do. So it's use the rational root theorem, state the possible rational roots, PRRs, or use the zeros for each polynomial. So let's look at an example. So I've got f of x equals 2x to the third minus 9x squared minus 7x plus 10. So the first thing I'm going to do is identify my p and my q. P is all the factors of the constant term. Q is going to become all the factors of the leading coefficient. So if I look at this list, it's already in standard form. So the constant term is the number that doesn't have an x with it. So it's the number by itself. That happens to be 10. So 10 is my P. My Q is going to be the leading coefficient. So what you're doing is you're going to look for the term with the highest exponent. That happens to be the first term. It's not always the first term, but it is. So this one has the highest exponent, or this is the degree of the polynomial. What I'm going to do is look at the whole term, 2x to the third, and the leading coefficient is just the number in front of the x to the power of 3. So it's just the number, not the variable. That's my Q. So I'm going to write P over Q and make sure you include the plus or minus signs. So for every single one of these combinations, I'm going to look at the positive and the negative value. So if you need to, make a little list for yourself. So if you have 10, think of all the numbers that you would multiply to get 10. 1 and 10, and 2 and 5. So these are all the numbers that multiply to get 10. So they're all the factors that multiply to get 10. So I'm going to write 1, 2, 5, and 10. On the bottom here, I'm going to write the list of all the numbers that multiply to get 2. Now 2 is prime, so it's just 1 and 2. Now I have to write my possible rational roots. That's all the combinations that might work when I use synthetic division to break down this polynomial. I have to use synthetic division because even though it has 4 terms, factor by grouping won't work. You won't get a common binomial. So unfortunately, and that's true, not all factor by grouping doesn't always work, or it's not guaranteed to work with when you have 4 terms. It will in the section of the test that I give you where it's factor by grouping. They're designed to work out that way, but it doesn't always work out that way. So what we do is we take the first term, and in other words, the 1 that's in the denominator, and I'm going to divide it into every term in the numerator. So 1 divided by 1 is 1, 2 divided by 1 is 2, 5 divided by 1 is 5, 10 divided by 1 is 10. Then I'm going to move over to the 2 in the denominator and do the same thing. I'm going to divide 1 by 2, 2 by 2, 5 by 2, and 10 by 2. If I get a duplicate, I'm not going to write down a duplicate. So we no duplicates. Let me actually write that here as a little note. No duplicates. All right. So 1 divided by 2 is 1/2. We don't have a 1/2, so we add it to the list. 2 divided by 2 happens to be 1 when we reduce it, and that's already in the list. 5 divided by 2 is not in the list, so we add 5 divided by 2. 10 divided by 2 is 5. That's in the list, so we don't write that. So here is our list of all the possible rational roots. And I can't stress this enough. Curly brackets around the list and the plus or minus sign. If you just put the plus or minus sign in front of the 1, you're telling me that 1 is plus or minus, but not the rest of the terms. So I will take off for that. Make sure you include that. So plus or minus, but you will need the curly brackets this time. Okay, moving on. Let's try, well, before we jump into one of these things, looks like, let's try number 20. That's the one I started. I think that'll be good. Let's look. The directions are changing, so we got to make sure that we do all of this. So it's using the fundamental theorem of algebra, state the number of solutions, then find all the possible rational roots from the rational root theorem, then find the zeros using synthetic division, and then using the quadratic formula. So let's get started. All right. So, and you may have to, again, glance back at the directions to be sure. The first thing, direction says, use the fundamental theorem of algebra to state the number of solutions. So all we have to do, again, this is already written in standard form. So find the highest exponent, 3, 2, 1, 0. So it's obviously the 3. That means we have 3 solutions. So that's the first part. The next part says find all the possible rational roots using the rational root theorem. All right, so that's where we go ahead and find our P. That's the constant term. Your Q is going to be the number in front of the leading term, or the one with the highest exponent. So this is a 1. So even though there's no number written there, it would not be a 0, because 0 times x cubed would mean the x cubed term would go away. So it's a 1. So what we're going to do, that's my Q value. We're going to do plus or minus the curly brackets. All the numbers that would multiply to get 20 go on the top. All the numbers that multiply to get 1 go on the bottom, or they're in the denominator. Now, that's easy for 1, right? Because the numbers that multiply to get 1 are just 1 times 1. But for 20, you might have to make a little bit of a list. So, because ideally, you want to write them from least to greatest. That'll make things easier on you. So I'm thinking 1 times 20. It's an even number, so 2 would go in. 2 times 10. 3 doesn't go into 20. 4 goes into 20. 4 times 5. It looks like that's it. So when I write down my list, I'm going to write it from least to greatest. So 1, 2, 4, 5, 10, and 20. So there's my list right there for all the p-values. Now, this list is kind of nice to work from because, again, when we're finding the PRRs are possible rational roots, it's always going to be plus or minus every number. Include the curly brackets. 1 divided by 1 is 1. 2 divided by 1 is 2. 4 divided by 1 is 4. 5 divided by 1 is 5. 10 divided by 1 is 10. And 20 divided by 1 is 20. So basically, we're writing down all the numbers that were in the numerator. So, and again, plus or minus out front, because the plus or minus applies to every single one of these answers. for the possible rational roots. And then we have to get started. Now, our instructions say find the zeros using synthetic division and then use the quadratic formula. So let's go ahead and do that. So here's x to the third minus x squared minus 12x plus 20. So if I look at this expression, it's not a quadratic, so I can't jump into using the quadratic formula. One of the things I check, does the polynomial have all positive values? If all the values are positive, then I'm going to pick a negative number from the list. If all the numbers are negative, then I'm going to pick a positive value, if that makes sense. Because when you use synthetic division, what are you doing? You're multiplying and adding, multiplying and adding, multiplying and adding. So if all of these are positive and I use a positive number, that number is just going to keep growing as I go through synthetic division. If it's negative, if all of these numbers are negative and I pick a negative number, that won't work either because I'll get a bigger and bigger negative number. So I need to be able to add or subtract. And the only way we're going to do that is if we introduce a negative if all of these values are positive, introduce a positive if they're all negative. So, and in a situation like this, where I've got two negatives and one positive, you kind of have to take potluck and just guess. So normally I will say this, I always recommend starting with the smallest number and working up to the biggest number. So I'm going to start with 1, then choose 2, then choose 4 and work my way up. I'm also going to avoid the fractions and use them last because not that you wouldn't need a fraction or it wouldn't work, but if I can avoid them, it makes things easier. I don't have to use those and just use the whole numbers or integers in my list. So I'm going to start with 1. So I'm going to remember to do synthetic division. You copy down all of the coefficients, making sure that if one is missing, you add 0 as a placeholder. So I'm going to copy down 1, negative 12, and 20. So again, 1, negative 12, and 20. Put a plus sign, draw a line underneath, and then to get started, I bring down the first number. So I'm bringing down the 1. 1 times 1 is 1. I'm going to write that answer in the next column over and then add them together. Negative 1 plus 1 is 0. 0 times 1 is 0. Negative 12 plus 0 is negative 12. Negative 12 times 1 is a negative 12. 20 plus a negative 12. All we know is that's not going to be 0, so we're done. All right, so again, I could use a positive or a negative number in this case because half of my coefficients are positive and half are negative. So let's try negative and see if that works. So I've got 1, negative 12, and 20. I'm going to start off with a negative 1. So bring down the 1, multiply 1 times negative 1. This time I get negative 1 and negative 2. That gives me negative 2. Negative 2 times negative 1 is a positive 2. So negative 12 times a positive 2 gives me a negative 10. Negative 10 times a negative 1 gives me a positive 10. 20 plus 10 is not going to give me 0, so that's not going to work either. So now I'm going to try another number in the list. I'll try 2. So for this one, I'll start with a positive. I could just start with a negative. It doesn't really matter. And again, copying down all the coefficients for the polynomial, 1, negative 12, and 20. Bring down the first term, the 1. 1 times 2 is 2. Negative 1 plus 2 is a positive 1. 1 times 2 is 2. Negative 12 plus 2 is negative 10. Negative 10 times 2 is negative 20. And then finally, 20 plus a negative 20 gives me 0. That means x equals 2 is a solution. So I'm going to quickly write that up. Oops, sorry. I'm going to go ahead and quickly write that up here so I don't forget about it. So I'm going to write down my 2. In fact, if you haven't, as soon as you find your PRRs, I would go ahead and write that in this list as well. So I would write down all of those numbers. All right, now let's go ahead and put our x's back in. Remember, for synthetic division, you kind of throw away the variables temporarily and then you got to put them back in. So this would be 1x squared plus 1x minus 10 equals 0. All right, so let's keep going. That means that a equals 1, b equals 1, and c equals negative 10. Remember, once you get an x squared term, then you're going to use the quadratic formula to solve the rest. How do we know if this is x squared? Remember, the original polynomial was x to the power of 3. You subtract 1, so 3 minus 1 is 2. So that means we're going to start off with an x squared term. So this term is always going to be x to a power that's 1 minus the original polynomial, what happens to be x to the power of 3. All right, so let's keep going. So this is going to be x equals negative b, so -1, plus or minus the square root of b squared, or 1 squared minus 4 times a, which is 1, times c, which is -10, all over 2 times 1, or 2a. Now, let's go ahead and finish this. We get x equals -1 plus or minus 1 squared minus 4 times 1 times -10. If you can do that in your head, more power to you, and then just check it with your calculator. That gives you the square root of 41. 41 is actually prime, so you could go ahead and try different numbers, but I think when you go ahead and do that, you're going to find, so for example, if I take, using our method that we used before, if I do 41, if I'm not sure, divided by 2, that gives me 20.5. So let's look at all the numbers that are prime. 1, 4, 9. Remember our list. 16, 25. Okay, 25 is too big. These are all the numbers that are less than 20, that are perfect squares. If I need to, I could try to divide 41 by 16, 41 by 9, 41 by 4. What we find is we were always getting decimal answers. The only one that wouldn't give us a decimal answer is the 1. So that would mean that 41 is prime. So my answer is x equals -1 plus or minus the square root of 41 divided by 2, and I'm done. And then I'm going to write that answer up here as my 0. Again, the plus or minus means I have 2 solutions, so 2 and 3, so 3 solutions, and I'm done. So I can stop at that point. All right, let's see if that's it. That is it. So, and again, good luck with everything. I think maybe we should do one more of these just for a warm fuzzy, because I know that these are rather complicated, and then I'll end the video. All right, so with this one, we've got 3x to the third minus 4x squared plus 5x minus 18. Remember, the first step is use the fundamental theorem of algebra to find the solutions. So all I'm doing is getting out the highest exponent. That's 3. That means my number of solution is 3. Done. Okay, the next step, we need to find our PRRs. How are we going to do that? Let's look at the constant term. That's -18. That's going to be my p-value. Let's find the leading term, the one with the highest exponent. Look at the number in front. That's my leading coefficient. That's my 3. That's going to be my q value. So I've got p and q. So the next thing I'm going to do is make a list of all the factors that multiply to get 18, and then all the factors that multiply to get 3. So if you need to, make a little list for yourself. So I'm thinking 18, right? 1 times 18, it's even, so 2 times 9. Ooh, 3 times 6, 4, no, 5, no, and then we're back where we started. So for me, I'm going to have to write down, and for you, when you're doing this problem, plus or minus, don't forget that, curly brackets, and then 1, 2, 3, 6, 9, 18. So you're just going to write them in order. It'll just make life easier for you if you go ahead and do that, although it's not a requirement. And then fortunately, 3 is prime. So the only numbers that multiply to get 3 are 1 and 3. So that's all the factors for my q. Then to find your PRRs, remember what we do. Start with the first number in the denominator. So it's going to be 1 divided by 1, which is 1. 2 divided by 1, which is 2. 3 divided by 1 is 3. 6 divided by 1 is 6. 9 divided by 1 is 9. And 18 divided by 1 is 18. Then we go back and do the same thing with the 3. 1 divided by 3 is 1/3. 2 divided by 3 is 2/3. 3 divided by 3 is 1, already there. 6 divided by 3 is 2, already there. 9 divided by 3 is 3, already there. 18 divided by 3 is 6, already there on the list. So we don't have to write anything. We don't want duplicates. All right, and again, it's plus or minus with curly brackets. I'm going to go ahead and copy that answer up here. So I've identified those are all the possible rational roots. Now, and you could have a polynomial with no rational roots. That won't happen for us because this is algebra 2. If I was in an advanced class, you would see that possibility. So we can guarantee that we're going to have rational roots. That also means that we may also have some, radicals. We also might end up with some solutions that are imaginary, but we'll find that out when we use the quadratic formula. All right, so again, this is a plus, this is a minus, this is a plus, and this is a minus. So half of my coefficients are positive, half are negative. So I don't really have any guidance as to where to start. So I'm just going to go ahead and start with +1. If that doesn't work, -1. Then I'll work up to 2 like I did before. So I'm going to put the 1 in the half box and then again, copy down the coefficients 3, -4, 5, and -18. So I'm going to copy down all of these numbers. It doesn't look like I'm missing any terms, so I don't have to insert a 0 as a placeholder. So make sure and always double check that when you copy them down correctly, including especially the plus and minus signs. So 3, -4, 5, and -18. So first thing you do after you complete the setup, bring down the 3, your starting term, or starting number, sorry. 3 times 1 is 3. -4 plus 3 is -1. This is looking good. -1 times 1 is a -1. 5 plus a -1 is 4. 4 times 1 is 4. -18 plus 4 is not going to give me 0. So boom, that's a bust. So let's try -1. So copy down the coefficients again. Bring down 3 as the starting value. 3 times -1 is -3. -4 and -3 is -7. -7 times -1 is a +7. 5 plus 7 is 12. Ooh, getting closer. But 12 times the -1 is -12. This is -18. We end up with a bigger negative number. Ugh. Okay, so let's try 2. So then again, copy down and set everything up, or bring down your starting value of 3, the first number. So 3 times 2 is 6. -4 plus 6 is 2. 2 times 2 is 4. 5 plus 4 is 9. 9 times 2 is 18. -18 and a +18 is 0. Eureka! We have got it. So we've found our first solution, x equals 2. So I would go ahead and copy that up here for your zeros so you don't forget to find it or have to look for it later or copy it later. So, oh, +2. Sorry, that should be a +2, not a -2. Fix that. Yeah, there we go. Sorry, that should have been a +2. All right, now let's keep going. So now remember we threw away, with synthetic division, you throw away the variables. Now let's bring them back. And again, this is an x to the third. So we're going to have, because we factored out an x with x equaling 2, we're going to have to go ahead and put it back in here. So, I mean, we're going to go ahead and subtract 1 from up here, not put it back in, subtract actually. So we'll have 1 less. So instead of having x to the third, we're going to write x squared. Sorry, been talking too long. Time to end this video. So I'm going to write 3x squared plus 2x plus 9, set it equal to 0. So now I'm going to go ahead and here are my coefficients, 3, 2, and 9. Those are my a, b, and c. Remember, a is always in front of x squared, b is in front of x, and c is always the constant term. And then just plug it into the quadratic formula. So negative x equals negative b, so -2 plus or minus the square root of b squared, or 2 squared minus 4 times a, which is 3, times c, which is 9, all over 2a, or 2 times 3. And remember, to extend this line, you're underlining everything up here. You're creating a fraction bar. You're actually writing a fraction, but you need to make sure everything gets underlined in order to do that. Now, keep going. So that's going to be x equals -2 plus or minus 2 times 3 is 6, and go ahead and, again, in your calculator, or if mental math, if you feel like you can do it, 2 squared, which is 4, minus 4 times 3 times 9. So I look at this and think 4 times 3 is 12. 12 times 9 is 108. So it's really just 4 minus 108. That gives us -104. And you know what I'm always saying is, as soon as you set negative, go ahead and break it out. So it's going to be the square root of -1, which will be I. So we'll worry about that later. What we really need to focus on is that 104 at this point. So again, let's go ahead and 104 divided by 2 is 52. So I'm looking at all the possible potential perfect squares that are less than 52. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64. Now I've gone too far. So here's my list. So I'm going to take the time to divide. If I don't know what it is, I'm going to divide each one of these into 104 to figure out which number. And actually, unfortunately, you end up getting as low as 4. And what I mean is, so I'm going to take, so for example, I'm going to use 104 to, oops, sorry, not multiply, divide by 49. I'm getting a decimal answer, so that doesn't work. So I go to the next one, 104 divided by 36. Decimal answer, so that one doesn't work. Just keep going. 104. I actually am not going to divide it by 25. You'd have to have a 5 on the end for it to be, or 0 for it to be divisible by 105. So I know that this one, you'd have to have a 5 or a 0 on the end for it to be divisible by 25. So I'm not even going to worry about that as an answer. So then I'll do 104 divided by 16, which you would think is a possibility, but it's close, but not quite, 6.5. So that doesn't work. 104 divided by 9 is 11.555. Again, doesn't work. So now I'm down to 104 divided by 4. Yay, that works. So the biggest perfect square that divides into 104 is 4. So I'm going to break this down into the square root of 4 times the square root of 26. So this becomes negative 2 plus or minus the square root of 4 times the square root of 26 minus 1 times the square root of negative 1. And notice I'm putting the perfect square first. So, and then all over 6. So let's go ahead and simplify that. Negative 2 plus or minus the square root of 4 is 2. The square root of negative 1 is I. And then the square root of 26. 26 breaks down into 2 times 13, but it doesn't break down any further. So there's no perfect square. And we know that anyway because we just looked at those numbers in that list back there when we divided 104 by 2 to get our starting point. All right, that being said, let's go ahead and say, look at the numbers outside of the radical. Do they simplify further? 2, 2, and 6 are all even numbers, so I'd say they're all divisible by 2. So when we divide negative 2 by 2, we get negative 1. When we divide 2i by 2, we get I times the square root of 26. Remember, we're not dividing the square root of 26 or 26 by 2. There's no need to do that because it's under the radical. Leave it alone. And then last but not least, 6 divided by 2 is 3. So my answer is negative 1 plus or minus I times the square root of 26 divided by 3. Those are my two other solutions. The plus or minus tells me that. So up here, I'm going to add negative 1 plus or minus I times the square root of 26 divided by 3. So now I have 3 solutions, and I'm good. I am done. So that is it. That's just an extra problem in that section because I know that that's a lot to do, and it's a lot on your plate. Good luck with everything, and hopefully you will do brilliantly on the test.